Alright, so we're going to talk about trig functions of any angle, and you should have been exposed to trig functions in general. Think of SOHCAHTOA or the unit circle, the trig functions of your unit circle. We're recapping some of those concepts in this section, so it shouldn't be too bad as a welcome back from your break. Okay, so let's talk about the definitions of trig functions of any angle. Remember that sine is the y on the unit circle. Remember that? Same concept here with the exception that you have to put it over the radius. Before you were on the unit circle, so the radius was 1 unit, right? So that's why it was just y. However, the radius is no longer 1. It depends on where a point is. So now it's y over r. Cosine on the unit circle, remember that corresponded to the x coordinate point, right? However, the unit circle had a radius of 1, so that's why we only looked at x. So now we're going to look at x over r. Tangent is still y over x. Cotangent is the reciprocal of that, so that's x over y. And notice that secant, the reciprocal of cosine, r over x. Cosecant, the reciprocal of sine, that's r over y. And we can put the point in any quadrant. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4, and that particular point lies in that particular quadrant, so we can create a right triangle in that particular quadrant. So let's take a look at an example. Okay, before I do that, don't forget positive rotations go in this direction, so counterclockwise, and clockwise rotations are your negative angles. Remember, we can convert back and forth from degrees to radians, radians to degrees, and typically when we're on a circular motion, we try to keep it within 2 pi. However, if it's over, remember to subtract 2 pi or 360 degrees, so that way you can actually take a look at the particular angle within 360 degrees that we're referring to. Okay, quadrantal angles, remember those are the angles that lie exactly on the quadrant, and I talked about this before. So if we're talking about, say, this point right here, 0 radians or 0 degrees, and let's put a point right here. Create a radius length. The easiest radius length to create for any quadrantal angle is the unit of 1. Okay, so here I want to go out to 1, 0. And then I can find the sine of, say, 0 radians. Remember, sine is y, so the sine of 0 would be 0. And that's what I should see here, and I do. Okay? So that's all this is showing you, whether you're in radians or degrees. What they've done on this chart, and this would be helpful in your homework assignment tonight, is that they pick the radius of a unit of 1 length. So if you ever have a quadrantal angle, again, that's an angle that lies exactly on the x or y axis. So here that would be a quadrantal angle on the positive x-axis, unit of 1, and then think back to your unit circle for those particular questions. Alright, so let's take a look at our first example. It says determine the exact values of the 6 trig functions of each angle theta. Okay, so this should be a wonderful recap to what we've done before. So what I like to do is I like to drop an altitude. Remember the distance, the horizontal distance from the origin out is your x. So that means this distance is 4. Okay, this is a right angle. The distance from the horizontal axis up to that point on the circle, that's your y. And not your circle, excuse me, the point on the triangle. So that's going to be 3. And now I'm just missing the hypotenuse. Okay, what is your hypotenuse? Pythagorean theorem. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. So 4 squared plus 3 squared equals, let's say, c squared. So that's 16 plus 9, which is? And c is therefore? 5. Good. So c equals 5. And notice that it's 3, 4, 5. That's your Pythagorean triple, right? Okay, so I could have done it either way. So now that I have that, notice that theta is this angle here. You can't tell too much from the diagram, but let me just make it a little clearer that theta is this angle in here. The inner angle of the triangle, and that's typically the angle that we look at. And now I want to find the 6 trig functions to theta. So again, SOHCAHTOA, or think of this as r. The c is r. So I can use that previous table that I just showed you where sine is y over r. and y is 3, and r is 5, and I'm done. I didn't need to draw that triangle. Or, being that I did draw the triangle, I can do SOHCAHTOA. Okay, so let's do cosine using the concept of SOHCAHTOA. So cosine, SOHCA, so that's adjacent over hypotenuse. So some options. Adjacent is going to be this distance here, 4, because that's adjacent to the angle, over your hypotenuse, which is 5. So 4 over 5. Or I can use the concept of x over r. That's going to give me 4 over 5. Let's find tangent. Remember, tan is y over x. Or SOHCAHTOA, opposite over adjacent. You can use either definition here. They will both work. So here y is 3, x is 4. And now I'm going to use the concept of reciprocal identities to answer my reciprocal functions. I just think it's easier to do it that way. You don't have to do it that way. You can use the definition of r over x, r over y, x over y. I don't care which one you use. It's all getting to the same solution. Okay, so let's find the reciprocal of tan, which is cotangent. I'm going to put them up at the top. Cotangent of theta is equal to, I'm just flipping over 3 over 4, so that's 4 over 3. Then I have cosecant of theta. Now I'm just flipping 3 over 5, that's 5 over 3. And then I have secant of theta. That's 4 over 5 flipped over, right? Because it's the reciprocal of cosine. And that answers 4 over 5. Okay, so in this one, we're still wanting to identify the 6 trig functions. Again, you have an option of creating a triangle, whichever method you like. Or you could just identify r. And remember, the concept of r is going to come from x squared plus y squared equals r squared. Or you can take the square root of that on both sides. And r is going to be equal to the following. R equals the square root of x squared plus y squared. Again, you can read that on that previous slide, or you can look behind me because I left that slide up, where r equals the square root of x squared plus y squared. So I don't necessarily have to finish my triangle. If I just have a coordinate point, I can jump to that concept. So let's do this one using that definition. Negative 8 squared plus 15 squared. R equals the square root of. Alright, and we end up with the solution here. Again, 8 squared is 64, 15 squared 225. We get 289, the square root of that is 17. Notice that I didn't write plus minus, I just kept the positive because we're talking about distance, right? So R is 17. Now I'm going to use the definition to find cosine of theta. Notice that this is theta here, right? Okay. We're always talking about, if we're looking at our triangle here, be careful. Here I'm using the definition on the chart of x over r. Careful where you put that angle if you do decide to do the triangle. Okay, so x is negative 8 and r is 17. I'm going to go ahead and find the reciprocal of that, which is going to be secant of theta, r over x, which is 17 over negative 8. Now let's find sine of theta. Remember, that's y over r. Y is 15, r is 17. Now I'm going to find the reciprocal of that, which is cosecant. So that's going to be 17 over 15. And now I'm just missing tangent and cotangent. Tangent of theta is y over x. So 15 over negative 8. And cotangent, negative 8 over 15. Okay, let's take a look at example 2. The point is on the terminal side of an angle in the standard position. Determine the exact values of the 6 trig functions of that particular angle. So here, if you want to, you can graph it and then create a triangle. Here, I'm not going to do that. I'm just going to go ahead and find r. Okay, remember that r is equal to the square root of x squared plus y squared. So I'm going to go ahead and I'm going to substitute that. R equals the square root of negative 4 squared plus 7 squared. Negative 4 squared. 7 squared. Add them, we get. Go again. Yeah. Okay, so we have the square root of 65. We have r, we have x, we have y. That's sufficient to finish this problem. So here let's start with cosine of theta equals, I don't like that color. Cosine of theta is what? X over r, and x is negative 4 over square root 65. Am I done with that problem? No, right? What do I need to do? Good, I need to rationalize my denominator. So the answer here is going to be negative 4 root 65 over 65. The reciprocal of cosine is secant of theta. I'm going to go ahead and flip this one over. Okay? Or remember, that's going to be r over x. And r we established is the square root of 65, and x is negative 4. Okay, the next thing I want is sine and cosine. I'm sorry, sine and cosecant. Sine of theta, that's y over r. Y, the given was 7. And r, we said, was the square root of 65. Again, we need to rationalize that denominator. So I'm going to multiply the top and bottom by the square root of 65. And we end up with 7 root 65 over 65. Okay. What's the reciprocal of sine? Cosecant. So we're going to do cosecant of theta. That says cosecant, by the way. So that's r over y. Or I could just flip this over. 7 over root 65. And I don't have to rationalize anything. So let's go ahead and do that. Root 65 over 7. And the easy one here is tangent and cotangent. Because I don't have to worry about root 65. I just put y over x and x over y. Tan of theta is equal to y over x. Y is 7, x is negative 4. Cotangent of theta is equal to x over y. That's negative 4 over 7. Okay, so recapping, here are your solutions. Here's cosine, here's secant, sine, remember that's y over r, cosecant, tangent, and cotangent. So here's x, y, r, so let's find cosine of theta. That's going to be 3 over 5. Secant of theta, 5 over 3. Sine of theta, negative 4 over 5. Cosecant of theta, 5 over negative 4. Tan of theta, negative 4 over 3. And cotan of theta, negative 3 over 4. So here's the solutions to this one. Again, try this one before checking your answers. Alright, so the signs of trig functions, something to remember is the concept of cast, C-A-S-T, where in quadrant 1, all functions are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, tangent and cotangent is positive. And in quadrant 4, cosine and secant are positive. Everything else is going to be negative in these quadrants except for that. Another way to remember that, going in order instead of remembering cast. If we're going in order, all students take calculus. So here's an acronym to help you remember that. Okay, so if cotangent is positive, that means we're going to be in this quadrant. Or which other quadrant? Okay. Quadrant 3. Whoever said that, good. Okay. So we're in these two quadrants. If sine is negative, because that's what the problem asks us, which quadrant does that narrow us down to? Quadrant 3. So let's take a look at this example. It says name the quadrant in which theta lies if cotangent is greater than 0, meaning it's positive, and sine is less than 0, meaning it's negative. Well, let's go. So we've established that this is true in quadrant 3, right? Okay. Again, remember the concept of cast, or all students take calculus. Cotangent, again, is only going to be positive in these two quadrants, and sine is going to be positive, negative, in these two quadrants. Okay? So our answer here is quadrant 3. Okay. given that cotangent of theta is negative 4 over 3 and sine is greater than 0, sine is positive. That leaves us in quadrants 1 and 2. Okay, so draw yourself a little picture, put CAS somewhere so you remember. All students take calculus. Sine, think of that as your y. Y is only positive going up, right? So quadrants 1 and 2. So that narrows it down to here. Okay, everything's positive in quadrant 1, so the only way you can have a negative sign is in quadrant 2. So this tells us we must be in quadrant 2. Let's draw a picture to represent cotangent as negative 4 over 3. So here's theta. Negative 4 over 3. Cotangent, remember that's x over y. So the negative, it could be the negative is either the x or the y. I have to establish it based on the quadrant I'm in. So be careful. So the x is always the top one for this particular one, and the y is the bottom one. The negative has to go to the x because x is negative towards the left on this axis, correct? So this distance, after I drop an altitude, create a right triangle, this portion of the triangle has to be negative 4. And the 3 has to be the positive direction for the y. Okay? And now I'm just missing r. R has to be what? 5. It's Pythagorean triple. Good. So now I can find sine, cosine, secant, cosecant. Notice that they didn't ask us for tangent, which is the reciprocal of cotangent. So let's go ahead and find sine. Sine is y over r, or opposite over hypotenuse. So this is going to be 3 over 5. Cosine is x over r, so what's our answer here? Negative 4 over 5, good. Secant is a reciprocal of cosine, so let's just go ahead and flip it. I'm okay if you write negative 5/4 or 5 over negative 4, either way you're good. And cosecant is the reciprocal of sine, so 5 over 3. Alright, example number 5, the terminal side of theta lies on the given line in the specific quadrant. Find the values of the 6 trig functions of theta by finding a point on the line. Okay, let's graph it. We begin at the origin because that's where the y-intercept is. Remember, it's y equals mx plus b. There's no b there, so that's plus 0. Our slope is 3 over 1, so I'm going to go up 3 units over 1 unit. Okay, we're going to pretend I connected the dots. And now we have the coordinate point 1, 3. I'm just missing r here. Remember, you find r is equal to the square root of x squared plus y squared. So 1 squared plus 3 squared, and then we're going to take the square root of that. So that's the square root of 10. Is that simplified? Yes. Okay. If you wanted to, you could create that right triangle and find your hypotenuse. I don't care either way you choose. You can either look at your coordinate point and r, or you can actually draw your triangle from this point here. Okay, now that we have that, we want to find the 6 trig functions. Notice that it didn't really specify the quadrant. I could technically be in quadrant 1, or I could technically be in quadrant 3. Had it been specific and told me that I'm in quadrant 1 or quadrant 3, then I have to go ahead and finish the line in that direction. But it didn't specify, it just says that it lies in the specific quadrant. It doesn't tell me 1 or 3, so I'm going to go ahead and go with 1. Okay? So now I can go ahead and find cosine of theta. Cosine, remember that's x over r. So it says to find a point on the line. The easiest point, I think, is just graph the slope one time. That's your point. So I picked 1, 3. You could technically from there continue the line segment by adding a slope to that and then picking that point, but why go more than once, right? So cosine is x over r. You have to rationalize your denominator, and you end up with square root of 10 over 10. Okay, let's find the reciprocal. 1 over root 10. When I flip that over, remember the reciprocal of cosine is secant. So that's going to be root 10 over 1, or just root 10. Then I want to find sine of theta, which sine is y, over r, which is square root 10. Rationalize that denominator, multiply the top and bottom by root 10. So here we get 3 root 10 over 10. And lastly, what I want to do is find the reciprocal of sine, which is cosecant. You can't see that. Cosecant of theta. I'm going to go ahead and I'm going to flip this over, because that's r over y. R over y. And don't forget tangent and cotangent. For tan and cotan, I'm only interested in the coordinate point. I'm not interested in r. Remember, tangent is y over x, so 3 over 1, which is 3. And cotangent is x over y, 1/3. Another way to have done this, you did not need to graph this. You could have picked a value for x and outputted your y. So let's say, just for the sake of this example, I picked x is 2, substituted 2 times 3 is 6, so I could have gone with 2, 6. Or if I picked 1, substitute your 1 in for x, you still get 3, so you still get that coordinate point. Okay, so evaluate the trig function of the quadrant, it should say quadrantal angle, if possible. This is what I was referring back to on that one table. Think about your unit circle when you have a problem that looks like this. What's the sine of pi? Okay, so if you allude back to just like your unit circle, keep it at a distance of 1 from here. Remember 0 pi over 2 pi, 3 pi over 2, and then we're back here, 1 complete rotation to 2 pi. Make your radius just a unit in length, 1 unit. So remember sine is y, so that will be our answer. Our answer is 0. Let's take a look at B. Okay, so this is the point that we're interested in here. Remember cotangent is x over y, right? So we're putting 0 over -1. Are we allowed to do that? Yeah, our answer is 0. Had it been -1 over 0, over the tan at 3 pi over 2, that's when it's undefined, so we would specify undefined. So let's talk about a reference angle. A reference angle is an angle of theta in the acute angle formed by the terminal side of theta in the horizontal axis. To find the reference angle, find the difference between the angle and the x-axis. So it's the acute angle formed by the terminal side of the given angle. For example, let's say this is the angle I'm referring to. Here's theta. Our reference angle is theta because it's already acute. So if you're in quadrant 1, that is your reference angle. Let's take a look at something in quadrant 2. So here's theta. Your reference angle is the acute angle formed by the terminal side and your x-axis. So in here, let's call that alpha. That is your reference angle. It's the acute angle being formed by the terminal side and the x-axis. So in order to find alpha in quadrant 2, what you're going to do is you're going to do 180 minus theta. Let's take a look at what happens when we're in quadrant 3. So here's quadrant 3. Again, your reference angle is the positive angle formed by the terminal side and the positive x-axis. So that's going to be in here. So that big green thing is theta. Let's put alpha in here. This is alpha. So if I want to find alpha, what I'm going to do is I'm going to do theta minus 180 if we're in quadrant 3. And if we're, so let's put a little memo here. Again, this is quadrant 1, this is quadrant 2, this is quadrant 3. If we're in quadrant 4, I'm running out of space here, so let's zoom in. So if we're in quadrant 4, let's draw our given angle is in quadrant form. I should be specific there. Here's our initial side. Here's our terminal side. Okay. Our reference angle is the angle that's being formed in here. Here's theta. How are we going to find alpha now? A reference angle being formed by the terminal side and the x-axis. Okay, good. So we're going to do 360 minus theta. If our given angle, theta, is in quadrant 4. And notice that this is just for positive angles. If I have negative angles, I'm going to think about what I just said to you guys and reverse it just a tad. This example number 7 says find the reference angle theta and sketch theta and its reference angle, or theta prime, in the standard position. So 2 pi over 3, that's in which quadrant? Is it greater than pi? No, 2/3, almost to 1, right? Is it more than a half? Yes. So that means we are in quadrant 2. So if we're in quadrant 2, what did I say to do? Good. Do 180 minus your given angle. What's the equivalent of 180? Pi. So we're going to do pi minus 2 pi over 3. Gives me pi over 3. If I'm graphing both of those, here's pi over 3. I'm calling this one alpha, by the way. And here's 2 pi over 3. Let's call that one theta. 9 pi over 2. 9 pi over 2. In order, you need to start by taking away 2 complete rotations from 9 pi over 2. So 2 pi is 1 rotation. And I can clearly see that a pi over 2 or 4 pi, two rotations over, is going to give me pi over 2. Okay? So pi over 2 is right here. This is the given angle. Let's call that theta. Now I want to find the reference angle. Well, is that already under 90 or under? Yes. This is your answer. This is what we're looking for. So this is the only thing you should be graphing. And if we're graphing 9 pi over 2, we just include those 2 rotations. So 1, 2, and 9 pi over 2. So the blue is 9 pi over 2. And when I take away the rotations, those 2 complete rotations, I happen to end up with my answer. Is that always going to happen? No. Sometimes we may end up in quadrants 2, 3, or 4, and then we have to take that additional step of finding the reference angle. So not only do I have to get it under 360 degrees, I have to actually find the reference angle, the acute angle formed by the terminal side and the x-axis. Alright, here's example 8. It says find sine, cosine, and tangent of the angle without a calculator. Well, 5 pi over 4, I can think back to my unit circle. Think about where 5 pi over 4 is. Good, that's in quadrant 3. So let's draw a quick picture so we don't forget where it is. So here's 5 pi over 4. If I create r with a distance of 1, that's going to give me an x and y coordinate of what? So on the unit circle, that should say negative, you can't really tell. It's negative x, negative y, root 2 over 2, root 2 over 2. So now we want to find sine of 5 pi over 4, which is going to be your y. Your cosine at 5 pi over 4, which is going to be your x. And your tan at 5 pi over 4, when I put y over x, anything divided by itself is 1. So notice that I did not use a calculator. I used the concept of the unit circle to help me answer this question. Alright, so now let's practice with our calculators. We're using our calculator to evaluate the trig function. We're rounding our answer to 4 place values. Remember, if you don't see a degree symbol, you're in radian mode. In your calculator, you should use the reciprocal function. So we're going to do 1 over the tan of 4.3 and we're rounding to 4 place values, so our answer is 0.4375. Secant, notice that we're in degree now, so make sure you switch your calculator to degrees. And secant, the reciprocal of that is cosine. So in our calculators, we have to do cosine 213 degrees. So cosine 213, and we're making sure that we do 1 divided by that. Round our answers to 4 place values. It's approximately negative 1.1924. Looking at example 10, it says find 2 solutions of each equation. Give your answers in degrees and in radians. Do not use a calculator. Well, here, sine at a half. The only time that sine is going to be a half is in terms of pi over 6. Pi over 6, specifically sine is positive only in quadrants 1 and 2. So our answer for theta has to be pi over 6. And what's in terms of pi over 6 but in quadrant 2? Okay, and 5 pi over 6. For part B, sine of theta equals negative a half. Well, it's only going to be negative in quadrants 3 and 4, and again, it has to be in terms of pi over 6. So what's our answer for theta here? 7 pi over 6 and 11 pi over 6. Good. And okay, on our final example 11, it says the displacement from equilibrium of an oscillating weight suspended by a spring is given by, and it's giving us a function, y of t equals 2 sine 6t, where y is the displacement in centimeters, and t is the time in seconds. Find the displacement when a, t equals 0, b, t equals a quarter, and c, t equals a half. So all we're going to do is substitute. It seems more intimidating than it is, I promise you it's not. What it's asking you to do is to literally substitute 0 into this function here, 1/4 and a half. That's it. Okay, so let's actually go ahead and do that. So that looks like this. So y of t equals 2 sine 6 times 0. So when we evaluate this one, what we want to do is evaluate 6 times 0 first. So we're going to rewrite it as 2 sine of 0. And what's the sine of 0 radians? It's 0. So we're going to have 2 times 0. So our answer is 0 here. The next one I want you to do is, that should have said 0 here. We're finding y of 1/4. Am I right? Yeah. Y of 1/4. So we're doing 2 sine 6 times 1/4, which is going to be 3 over 2. First, find sine at 3 over 2. Use your calculator. And then multiply that by 2. And make sure you're in the right mode. I was not in the right mode just now. You have to be in radians. So the sine of 3 over 2. Multiply that by 2, and our answer is 1.99. And we're in centimeters, right? Am I right in saying? Yep, 1.99 in centimeters. It doesn't tell us to round, so let's just keep it 1.99. So 1.99 centimeters. And our last one, y equals 1/2. So we're going to do 2 sine, y of 1/2 equals 2 sine 6. Take half of that, so we're going to do sine of 3. And then multiply that by 2. And our answer is 0.282 centimeters.